Taking a look at the next question. A student carries out an experiment to find the relationship between the pressure P and volume V of a fixed mass of gas. The table contains 4 of her sets of measurements. So we notice that as pressure is incremented in equal steps, volume V seems to be decreasing. Use the data to suggest the relationship between pressure P and volume V in this experiment. Explain how you reach your conclusion. We can try to find out the multiplication or the multiplicand value of pressure times volume, or P times V. And we notice that in every instant, the value P into V remains a constant at about 7,500 in every case. This tells us that pressure times volume V is remaining a constant, or pressure P is inversely proportional to the volume. Moving on, state the property of the gas apart from the mass that remains constant during this experiment. So during this experiment, that is an experiment where pressure is inversely proportional to volume, or pressure and volume are both variables, the temperature remains a constant. A lake is 5 meters deep. The density of water is 1,000 kg per meter cube. Calculate the pressure at the bottom of the lake due to this depth of water. We can calculate pressure due to a liquid as pressure P equals rho G H, where rho stands for density, G stands for the acceleration due to gravity, and H stands for the height. So substituting, density is 1,000 kg per meter cube. G is a value taken from the data booklet as 10, and height H is 5, giving us the value of pressure as 50 kilopascal. Moving on, a bubble of gas escapes from the mud at the bottom of a lake and rises to the surface. Place one tick in each row to indicate what happens to the volume, the mass, and the density of the gas in the bubble. Assume that no gas or water vapor enters or leaves the bubble. We know that volume of the bubble will increase, and while volume increases, mass is a constant. Mass cannot change. So mass remains a constant. And while volume increases, making mass still a constant, density has to correspondingly decrease, since the relationship between density, mass, and volume is density is equal to mass over volume. And since mass remains a constant, density is inversely proportional to volume, making the density decrease.